All right, number 11. We have a hemispherical tank with a radius 8 meters. It's filled with an inflow pipe at a rate of 4 meters cubed per minute. And we have a figure right here. We want to know how fast the water level is rising when the level is 6 meters from the bottom of the tank. And then it gives us the volume of the cap thickness H sliced from a sphere is given. Okay. So we are given radius is 8. We are given inflow rate. So that is dV dt, the rate at which the volume is changing. I know that that's the volume because I'm in cubic meters. So that is 4 meters cubed per minute. Okay, volume is cubic, 3-dimensional. We want to know how fast the water level is rising when it's 6 meters from the bottom. So we are looking for dH dt when H is equal to 6m. Okay, and we are given the formula for the volume is pi h squared 3r minus h, all divided by 3. Now for this formula, we're going to take the derivative. However, r is a constant, and instead of having to do the product rule, I might go ahead and distribute, and then I can factor out the constant. So when I do the derivative, I don't have to do the product rule. So radius is 8, it is fixed. I'm going to go ahead and plug that in. And then we're going to distribute on the top to simplify. So this pi over 3 is just a constant. We can pull that out. Volume equals, and we'll just say pi over 3. And then here we'll have h times 24. So we'll get 24h squared. And then h squared times the negative h will be minus h cubed. Okay. So here's my volume, the pi over 3, we just put it out front, distribute 3 times 8 for our radius, gives us 24, and then h squared times negative h will give us negative h cubed. From here, we're going to take the derivative, dv dt, pi over 3, and then the derivative, 2 times 24 will give us 48h times the derivative of h, dh dt, and then minus 3h squared dh dt. And then from this point, we can plug in our 6. And we can factor out the dH dt and plug in our rate of change. So this is 4 meters cubed per minute, pi over 3. I'm also going to factor out the dH dt. Pull that outside. It's going to be 48 times height of 6 meters. Now this 48 should be just in meters. Give me meters squared minus 3 times 6. That'll be squared. And that 6 is in meters. So that right, meter squared, and then times that'll give me meter squared. So we have 4 meters cubed per minute equals pi over 3 dH dt. 48 times 6. We can think about that as 6 times 50, which will give me 300. And 6 times 2 is 12. So 300 minus 12 is 288. We'll check that in a minute. And then we get 36 times 3, 72, 108. And then from here we'll just solve for dH dt, and then that'll give us what we need. So we'll multiply by 3. Well, I guess I can just do it all at once. 4. 208 minus, I'm sorry, 288 minus 108 will give us 180 dH dt. 180 divided by 3 is 60. So basically we'll divide by 60 pi. So dH dt is equal to 4 meters cubed per minute divided by, this will be 60 meters squared times pi. You're dividing by this to get it away from dH dt. So here's our answer. We want to round to 3 decimal places, and that'll be meters per minute once the variables settle. Let me double check all this math just to make sure. 48 times 6 would be 288, and 36 and 3. Okay, so 4 divided by 60 times pi. 0.021. 0.021. That will be meters per minute.